All right, so in this lesson, which is on writing or creating polynomial models, polynomial functions that model situations using our skills of addition, subtraction, multiplication, or a combination of those. We're jumping right in to one of our first example here. And as you can see, compared to like our first semester when we did this with simpler polynomials, now many of our problems have a little bit more reading going on because we are looking at we've moved up in the math world for our modeling expectations. So always read the problem. Again, it's a good strategy to use color. You can to highlight different aspects of the problem, as I will demonstrate here for you. You can use colored pencils or pens if you don't have highlighters. It's just a way to help different parts of the problem jump out at you more easily so your eyes can find what you need to find in a situation. Problem like this. So here it says the data from the U.S. Census Bureau for 2005 to 2009 shows that the number of male students in thousands enrolled in high school in the United States can be modeled by the function m of x, where x is the number of years after 2005. The number of female students in thousands enrolled in high school in the United States can be modeled by the function f of x, where x is the number of years after 2005. I'm going to go ahead and read part A, okay, and then we'll start talking about how we can break this down. So part A says that we're to write a new function t of x that models the total number of students in thousands after 2005. All right. So good strategy would be to, in different colors, highlight or underline your two different functions, what they each represent, and then also what your x variable is defined as. So here we have this function m of x. And m of x, we are told, represents here the number of male students in thousands enrolled in high school in the United States. Our other function here, f of x, we are told that this represents the number of female students in thousands enrolled in high school in the United States. We are also told in both situations, notice, that our x variable represents the number of years after 2005. That piece of information that I've highlighted there in orange generally becomes most important for part B problems, where we're going to, or problems in general, where we're going to have to use a value of x and evaluate the function and then write a conclusion about what that means. Is understanding how x is defined is necessary when we have to plug in an x number and then evaluate and make a conclusion. For our part A, it doesn't really matter how x is defined, except for the fact that we know x is defined the same way, which then allows us to combine the two functions in some way. So here, what I'm looking at, I'm supposed to write a new function, and this new function, notice, is given a name, t of x. So just like I was mentioning in the previous lesson, when you're writing a function, your answer is not correct unless the function has its name at the beginning. And the name we are told for this function is going to be t of x. So we need to make sure our final answer will start with t of x equals. This new function, we are told, needs to model the total number of students in thousands after 2005. The key part of this is that what it models is the total number of students. So we have to understand mathematically how to get a total number of students from the two functions that represent male students and female students. So hopefully you're thinking, okay, well, total would mean all of the students. And if I want all the students, then I would take the male students and the female students and put them all together. Now I have to understand that the correct operation for that would be addition. So like, if I have in a class 12 males and 13 females, the total number of students would then be the 12 plus the 13, which would then in that case be 25 students. So, and that strategy that I just modeled for you is a good one for if you're not sure whether you should add or subtract or multiply or whatever, is take it out of all of the X stuff and just give yourself some numbers to work with and think about it that way. Say, well, what if there were 12 male students and there were 13 female students? What do I know about combining those to get the total number of students? And that can be easier to see rather than trying to figure it out sometimes from the X's situation. So given that we've now determined that to get the total number of students we have to add, what we're going to have to do then is take our m of x function and add it to our f of x function. And that's going to be our t of x function. Now, how you structure this addition is sort of up to you. Like if you want to write a big, giant, long, horizontal string of all of your terms, you can. I like lining things up vertically in a problem like this with my like terms. So I'm going to start with my terms for m of x. And it's already in standard form, so I'm just going to keep them that way. So I have this negative 10.4x cubed plus 74x squared minus 3.4x plus 8,320.2. One of the biggest things here in a problem like this is accidentally not copying the numbers correctly or losing a decimal point, things like that. So just be careful. Always double check and make sure you've copied things correctly. So now I'm going to take my f of x terms and line them up below the like terms. So this would be negative 13.8x cubed, then plus 55.3x squared, plus 141x, plus 7,880. Now remember, we've earlier determined that we need to add these together. So adding doesn't change signs, so we'll keep the signs of my terms in black here for f of x and just combine them with the terms in red. And if all of a sudden you're wondering, am I going to have to do that without a calculator? No, you're not. So in a problem like this, a calculator does become an appropriate tool, and we will be allowed to use one for a problem like this. So let's grab our calculator and combine our like terms. All right, so using our calculator here to combine these, we now have a negative 24.2 x cubed, and then plus a positive 129.3 x squared, and then plus a positive 137.6 times x, and then plus a positive 16,200.2. And just like I said yesterday, remember, is this what I have in green, my final answer? No, it is not, because I'm supposed to write a function, and my function isn't done until it has its name, which is the t of x. So I want to make sure that my answer starts with t of x equals. Now I've finished my function for part A. All right, so now moving on to part B. Now be careful, don't make assumptions. Lots of times part B will have you use your function in part A, but it doesn't have to. It could actually be a question that uses one of the original functions, such as m of x or f of x. So always read carefully what you are evaluating. So here we are to estimate the total number of students enrolled in high school in the United States. And so because I am estimating a total number of students, and t of x is about total, then I'm going to use t of x. It says that I want to estimate for the year 2009. So in order to use t of x, I need an x value. And here is where it's important to have paid attention to how x is defined. I highlighted that in orange here. X is defined as the number of years after 2005. So we should not be plugging in 2009 to x, because that's not equal to the number of years after 2005. So x, we have to realize, would be our 2009 minus 2005. And that would tell us it's 4 years after 2005. And so we use 4 for our x value. So now what we're going to do is figure out t of 4. So I have now my negative 24.2 times 4 to the third power plus 129.3 times 4 squared plus 137.6 times 4 plus 16,200.2. Now, if you have a calculator like mine, where you can just type in what you're looking at here in green from left to right, then I would say just do that. And you would just, for your exponents, after you type in the negative 24.2 times, you would do 4 exponent 3, hit plus, and then continue times 4 exponent 2 or 4 squared, and then you just keep going until your end. If you have one of those calculators that has you do it backwards, I'm going to recommend that maybe what you do is simplify your powers first and just write them as whole numbers instead of trying to do it all at once. Because doing it in the backwards, you can get a little lost in your math, but you're welcome to try it both ways and see, if you can be successful doing it as 4 to the third power rather than rewriting it as 64. But you might want to consider just doing negative 24.2 times 64 plus 129.3 times 16, and then just doing, the rest. All right, let's see what we get. Okay, so if you are doing these calculations with me, hopefully we're agreeing. I have an answer of 17,270.6. Now, here's where we ask ourselves, does this seem like a reasonable answer? So this answer is supposed to represent an estimate of the total number of students enrolled in high school in the entire United States in 2009. Based on what you know about the population of the United States, does it make sense that little over 17,000 total students are in high school in 2009? Hopefully you're saying no, that seems awfully low for a situation like this, because it is, because the population of the United States is in millions, so having only 17,000 teenagers in high school doesn't make sense. So what have we forgotten, or what do we still need to do at this point? Well, you remember how it said up here that M of x was male students in thousands, and f of x is female students in thousands. Well, that means that our t of x is total number of students in thousands. And it actually says it right here, but doesn't always do that for us. Which means that we have to take this and multiply it by 1,000 in order to get the true correct number. And you can use your calculator, but it also you should know your basic math here. It moves your decimal point 3 places to the right. So I now have 17,270, and then 6, and then 2 extra zeros. And so now it's telling me 17,270,600 total students, which makes more sense based on what we know about the population of the United States. So now, the last thing that I'll need to do for this part B is write a conclusion. So I'm going to say that I'm going to start with my year in 2009. So in 2009, the total number of students enrolled in high school in the United States and this is past tense since 2009 is in the past, so I'm going to say was about, because remember this is an estimate. So even though I did no rounding at all in my math, this claims that I'm actually estimating the total number of students. So I'm going to say about because of that. 17,270,600, like so. All right, so let's take a look at this next example. Again, got a bit of reading here. So it says from 1995 through 2010, the yearly gross revenue in millions for a candy company can be modeled by the function R of t. And the yearly cost in millions can be modeled by the function C of t, where t is the number of years since 1995. So part A says that we are to write a new function, P of t, that models the yearly profit after 1995. So we are writing a new function. Our new function is given the name P of t, so we got to make sure that answer starts with P of t equals, and it is supposed to model or represent the yearly profit. So this concept of profit may or may not be something that you're familiar with on how it relates to the given information. So in this it says that our R of t, so R of t is this function, and it's broken, notice, on the line. So that's why highlighting is again very helpful here. And what it models is the yearly gross revenue in millions for a candy company. So it represents what we call as revenue. Gross just means total, okay? All or total. All the revenue. Our other function says that C of t, shown here. We're told that this represents the yearly cost in millions, which we would assume is in dollars. And so how is profit related to revenue and cost? In other words, how do we take revenue and cost and create mathematically what we call profit? So this is one of those things where if you don't know it, now you're learning this relationship. And when profit problems like this come up in the future, then you will know, okay, then you'll be ready to do them and you'll know that relationship. So what is true about profit related to revenue and cost? Revenue is like all of the money that the candy company made from selling their candy. And cost is all of their bills. Profit is what we define as the money that's left over after all the bills have been paid. So again, profit is the money left over, or the money that remains after all the bills have been paid. And the bills are the costs. So that tells me that my profit will come from subtracting costs from revenue. So I start with my revenue, all the money the company made, and I subtract off all those bills, all the costs, and what's left will be profit. So this is telling me that P of t will be equal to r of t minus c of t, like so. So now, here remember, r of t has to go first because subtraction, I cannot change my order. So r of t, I have, and I'm going to do this one horizontally just because it's easier for me to show the subtraction that way. So I'm starting with r, which is my 0.01, and it breaks, so I want to make sure I don't lose anything. T to the third power minus 0.2677 t squared plus 1.7779 t plus 2.1805. And now I'm going to subtract from that. I guess I should technically put parentheses around this like we did the other day in the previous lesson, but those parentheses won't matter. The parentheses after in the second one are going to matter. So now I'm subtracting the costs. So I'm subtracting all four of these terms. The 0.0008 t cubed minus 0.0096 t squared plus 0.0288 t plus 2.4. So do you remember what we talked about in the previous lesson? When we're subtracting all of this, what do we have to do before we can combine our like terms? Is we have to change all four of the signs of what I have in these parentheses for what I'm subtracting, which is c of t. So my positives turn to negatives and my negatives turn to positives. So when I distribute this, this is going to become a negative. So I have a net minus 0.0008 t cubed. And then I'm subtracting this negative, so that becomes plus a positive 0.0096 t squared. Then I'm subtracting this positive, so it's now a negative. So I have plus a negative, or you can just write minus 0.0288 t. And I'm subtracting another positive, so you can either write it as minus or plus negative 2.4, like so. So now we're just going, I have already done my subtraction, so now I'm just going to combine my like terms. By doing my subtraction, I mean I've distributed my negative sign, so now I'm going to combine my like terms with the signs that I currently have in green. All right, let's use a calculator now to help us with that. Okay, so I've got now 0.0092 t cubed minus 0.2581 t squared plus 1.7491 t minus 0.2195. And then, again, is what we have in orange our final answer? Nope, not quite, because if it's a function, it needs its name. Its name, remember, is p of t. So I'm going to take that name, put it in front. So p of t equals, and now I have my function for part A. All right, so let's take a look now at part B. So now remember, part B can often be about using your function from part A, but not always. So always be careful to read carefully and make sure. So this says what was the total profit the candy company had in the year 2007. So we are calculating a total profit, and remember our P of T models our profit, and yearly profit is going to be the same thing as our total profit in a particular year. That's what that means. Now, the part that we did not highlight earlier is, well, what are we supposed to use if we're doing P of T? If we're going to use our P of T, what are we going to use for T? And that, remember, is something we have to figure out based on how T is defined. So here it tells us T is the number of years since 1995. So that's telling us our T would be taking our year of 2007 minus 1995, which gives us 12. So it's 12 years since 1995. So we're finding P of 12. So P of 12, we've got this 0.0092 times 12 to the third power minus 0.2581 times 12 squared plus 1.7491 times 12 minus 0.2195. So in using your calculator here, you can just type it in. If you have a calculator that allows you to just type it in as you see it. If you don't, if you have one of those calculators that kind of does things backwards, then you might want to figure out what 12 cubed and 12 squared are first, and then just type it in as a multiplication for those parts and do it kind of in 2 steps like that. All right, let's use our calculator and see what we get. Okay, so hopefully you're agreeing with my number. I'm coming up with negative 0.4991. So now we have to figure out what does this mean in this situation. We also, remember, have to consider, well, by itself, does it make sense? And realize, nope, wait, there was something else about how things were defined here. Remember how it said our revenue is in millions and our cost is also in millions, which means that our profit is in millions also, because it came from those two functions. So this by itself isn't the correct number. We need to now take this times 1 million. And that is going to move our decimal point 6 places to the right, 1 for each of those zeros. And so we still have a negative, and this would be our first 4991, and then 2 more zeros gives us a total of 6. So now we have this negative 499,100. So what does it mean if our profit is a negative number? Well, that actually means that the company lost money. So if that's what you're thinking, good. Yes, if your profit turns out to be negative, that means that the company actually didn't make any money. They actually lost money. Their bills were more than their revenue. So we are going to say here that in 2007, the candy company actually had a loss or a negative profit, if you want to say that. But usually we just call it a loss. So I'm going to say that here. So in 2007, the candy company had a loss of, and then I have my dollars. Some of you, I know you write dollars after the number, and that's okay too, but this is the more common way of showing our money for the United States. So $499,100, like so. All right, that finishes that one up. All right, so taking a look now at this third example. In our situation up here in the box, it says that a straight section of a biking path has a width in feet modeled by the function w of x and a length in feet modeled by the function L of x. Part A says we're to write a new function p of x that represents the perimeter of the bike path section. So we need to understand how to create perimeter from our given information, which is that we have w of x, which is the width in feet of the path, and we have L of x, which is the length in feet of the path. So this is something that is supposed to be in our prior knowledge, so something we've already learned. But sometimes we forget these things, so we're going to go over it. So when you have a length and the width, it's creating a rectangular shape. So this strip of biking path would be shaped like a rectangle. And perimeter, we have to realize or remember, is then measuring the distance around all four sides. So if you start at one corner, perimeter goes all the way around and back to the starting point. And so the widths, there would be two of them on those ends, and the lengths, there would be two of those. And so what this tells us is that we can find the perimeter of this bike path section if we add up two lengths and two widths. Now you can do them individually, but I recommend that you use one of the shorter forms for perimeter of a rectangle. So either use that your perimeter equals 2 times the length plus 2 times the width, or you could use your perimeter is adding your length and the width first and then multiplying that times 2, whichever one you prefer. And so they're both good ways to do this particular problem. In some ways, I think the second one might be a little shorter in the amount of work that we do if we add L and W together first and then just multiply each of those terms by 2. So that's what I'm going to do here. So for my first step, I'm going to do L plus W. So my L is my x cubed plus 4x squared plus 5x minus 6. And my W that I'm adding to it is my 2x plus 7. So combining those, these guys will combine and these guys will combine. So this is going to give me x cubed plus 4x squared plus 7x plus 1. So then my second step will be taking it times 2. So I'm going to do 2 times what I have over here. My x cubed plus 4x squared plus 7x plus 1. And you should always write your functions in their standard form, which means you got to do all the math. So this is 2x cubed plus 8x squared plus 14x plus 2. So now remember what we were doing, how we were writing a new function given a name of p of x. So now I want to make sure my answer starts with p of x equals, and I'll use what I had here. So p of x equals 2x cubed plus 8x squared plus 14x plus 2. Like so. There's part A. All right, so now for part B, it says find the perimeter. So that means we're going to be using our perimeter function, p of x. And we want to do this if the width is 17 feet. This is where this one gets a little tricky because it never said the width is x. So 17 is not our x value, and we have to realize that here. The width is x. How is width defined again? Remember? Width is 2x plus 7. So the first thing we have to do here is find our x by using that our width is 17 feet, and our width is w of x, which is 2x plus 7. So our w of x, which is our width, is 17. And it creates this little simple, it's a simple algebra equation, but we have to understand that we have to do this. So subtracting 7 from both sides, I now have 10 equals 2x. And dividing both sides by 2 tells me, oh, my x is 5. Now I can figure out my perimeter. So I'm figuring out what is p of 5. So I'm going to do 2 times 5 to the 3rd power plus 8 times 5 squared plus 14 times 5 plus 2. All right, so let's figure out what that is. And we can use a calculator there to help us do that more quickly. All right, so here we're hopefully getting 522. So remember, this represents our perimeter, and our perimeter is measured in feet since we're adding up all of the feet from lengths and widths. So it's feet plus feet plus feet plus feet, which is feet. And now we can write our conclusion that the perimeter of the described section of the biking path is 522 feet. All right, that finishes that one up. Let's move on to the last one here. All right, so here it says that a farmer has a field he needs to mow before he can plant wheat. The length of the field can be modeled by L of x feet. And the width of the field, whoops, I was supposed to change colors. The width of the field can be modeled by W of x in feet. Here in our part A, we're to write a function a of x that models the area of the field. So here we have to remember, okay, length and width, we get a rectangular shape again for our field. And that when we figure out area, that it's length times width. So this is telling us our a of x is going to be our length times our width. And it doesn't really matter which one we put first, but they're both trinomials, so also it doesn't matter for that. So I'm going to take my L of x, which is 5x cubed, plus 2x squared plus 7, times the 3x squared minus 4x plus 2. Distributing. So first I have to distribute my 5x cubed, so I get 15x to the 5th minus 20x to the 4th plus 10x cubed. Then I have to distribute the 2x squared, so I get plus 6x to the 4th minus 8x cubed plus 4x squared. And lastly, I distribute the 7. So that gives me a plus 21x squared minus 28x plus 14. And also, I don't want to lose my function's name. So I'm going to start with a of x equals, combining my like terms, 15x to the 5th minus 14x to the 4th plus 2x cubed plus 25x squared minus 28x plus 14. That's a long one, but at least the numbers were easy to work with this time. Didn't really need a calculator. All right, so now it says the farmer can mow the field at a rate of 1,000 square feet per minute if the value of x is 8. So here they're nicely just telling us x is 8. How long to the nearest hour will it take the farmer to mow the field? All right. So what we have to realize if this is area, if my function in red is area, and length and width were both in feet, then this was feet times feet. So this is my square feet answer. So when I plug in 8 and I figure out what is a of 8. I have 15 times 8 to the 5th power minus 14 times 8 to the 4th power, and so on, that this number is going to be in square feet. All right, so that's where we start. So I'm going to do that math first with my calculator. All right, so this turns out to be 436,590 square feet. Now, remember what we wanted? We wanted to know how long to the nearest hour it's going to take the farmer to mow the field. What we have to see, remember all those volume problems where we did all those conversions? We have to see this 1,000 square feet per minute as a conversion ratio. That 1,000 square feet equals 1 minute. So I'm going to take this, which has a denominator of 1, and multiply it to get rid of my square feet. So I put my 1,000 square feet down here and 1 minute up here. Here's the next tricky thing about this problem. This will get rid of square feet, but I'm left with minutes. I don't want minutes, I want hours. So that means I now have to convert my minutes to hours. And we know that there are 60 minutes in an hour. So I'm going to put my 60 minutes down here, 1 hour up there. So now I get rid of minutes. Now I'm going to have hours. And my math tells me to take my 436,590, divide by 1,000, and divide by 60, since they're both in the denominator. So I have to divide by 1,000 and divide by 60. That's crucial. So let's do that. So now I get 7.2765 hours. And nearest hour, remember that wording means whole number, which is our ones place. So this is going to tell us that this is about 7 hours. And now we can write our conclusion. So I'm going to say it will take the farmer about 7 hours to mow the field. Alrighty. So that does end this lesson and gives you some good examples to help with the assignment.